This video is going to be on combinations. So combinations are similar to permutations. This is our permutation formula over here, but combinations are slightly different in that they have this extra r factorial here. Now, before we deal with the formulas, let's just talk really quickly about the difference between a combination and a permutation. So a permutation is all the different ways I could arrange things. So you could think of all the different ways you could arrange three numbers. That would be all the different permutations, right? You could have 1, 2, 1. You could have, so for example, 1, 2, 1 would be a different permutation than 1, 1, 2. They're the same three items, but these would be different permutations. For combinations, it's similar to permutations. You want to know all the different combinations, but the order is unimportant. So this would actually be all part of these three permutations would all be just one combination. So basically combinations are like permutations, but not counting the multiple permutations that have all the same items. So this would just be one combination here. If you want a much better, more in-depth explanation of that, go to this combinations formula video. I think they do a nice job of explaining where this formula comes from. But the key thing to notice is it's the same as the permutations formula, but there's this additional r factorial. And basically what this means is you find the number of permutations first, and then you're going to divide by r factorial because you want to make sure you're not repeating permutations that have the exact same items. Even though they're different permutations, they are not different combinations. So it makes sense that often our combinations will be less than our permutations. They will never be more combinations than permutations. And that's because we're dividing by this extra factor mathematically, but logically it makes sense too because you're not repeating permutations with the same items. Just a quick reminder, n stands for the number of items, r stands for the number of positions, or they say r at a time in this case. So let's look at this in an actual problem. You'll see these aren't too terrible. So we want NCR, and that will be equal to n factorial over parentheses n minus r factorial times r factorial. Okay, and so we need to figure out what n and r is in all these problems. That's basically what they're asking, and then you use the formula to calculate. So in this case, we have 9 unique toy animals. That's our n. And our r in this case is 5. He only has space for 5 of them in his bag. So our r is 5. When we put this in our formula, we have NC5. So finding combinations of 9 items with 5 positions is going to be 9 factorial over 9 minus 5 factorial times 5 factorial. I can clean this up just a little bit by calling this 9 factorial over 4 factorial. 9 minus 5 is 4 times 5 factorial. So for me to find 9 factorial, I'm going to say fact 9, but that's probably not what your calculator is going to do. Your calculator will probably be something like this. But this calculator does different things sometimes, so it's not going to look like this for me, but just keep in mind, this for me means that for you. So just replace fact with an exclamation point after the number in your own calculators. So I want to do 9 factorial divided by 4 factorial. So 4 factorial, and I want to multiply this by 5 factorial. And when I do this, I get 126 different possibilities. So that's actually a lot, but he has 9 toys. So they're saying there's 126 different ways to arrange that. So that's pretty cool. And just to give us another perspective, if we didn't have combinations, if we were just thinking of different permutations, there would actually be 15,120. So there are way more permutations than there are combinations sometimes, and that's fine. But our final answer is, I need my multiplication symbol, 126. Okay, and that's basically how we're going to do all of these. So let's look at another example. All right, so my NCR equals n factorial over n minus r factorial times r factorial. All right, and we need to figure out what our NCR is in this case. So she has 5 unique shirts. That looks like n. And she has 3 places to put those, so 3 positions. So r is equal to 3. And so if I want to do this, I'm going to have 5c3 equals 5 factorial over 5 minus 3 factorial times 3 factorial. And so in this case, it'll be factorial of 5 divided by the factorial of 5 minus 3 is actually going to be 2 times the factorial of 3. And so we end up with 10 different possible combinations for her 3 shirts. Now, one thing I want to point out here is you might be wondering, where did this fact 2 come from?